Hey, Year 12s, welcome to Monday's lesson on compound interest. So, Friday we had a look at what simple interest is. Compound interest is real life interest. So, this is probably the most relevant topic out of all of further maths because down the track, I'm sure you all have bank accounts now, but perhaps you'll in the future want to own a house, perhaps in the future you want to, save money and pick the right bank account for you. So how do we pick which one's the best one? Let's take a look at what compound interest is. Compound interest is interest that's recalculated each year or the compounding period. So the way banks work is, just have a think. I'm sure most of you have a savings account. At the end of each month, you receive a certain amount of money, and that's called the interest. Now, the bank calculates most accounts' interest on a monthly basis. Right? Sometimes you might have daily agreements, sometimes you might have fortnightly agreements, sometimes you have biannual agreements, but generally speaking, it's usually monthly. Okay? How they do that? Well, let's take a look at the example. So here we've got Alan. Alan inherits 35,000. So inherit means gains. So someone passed away or handed him $35,000 for whatever reason, and Alan decides to invest it in an account where he earns 6% per annum or per year, and it's compounded monthly. Right, so we always have to underline the key details. This italicized text might change. Could be daily, could be weekly, could be fortnightly, could be biannually or annually. Okay, but here we've got a monthly example, and let's just highlight it so you guys definitely don't miss it. All right, because you'll see why in the working, why this is important. So the first step to calculating how much interest he earns. Okay, so he's investing, he's going to earn interest. If he were to borrow money, he would have to pay interest. Okay, so invest, you earn, borrow, you pay. Part one, or part A, find R, or the rate, the percentage interest rate per compounding period. Right, so it's being compounded monthly, so what we do is we take this 6% and we turn it into a decimal, so 0.06, and we divide that by, well, monthly, there's 12 months in a year. Remember, this is why we did that pre-test. We would divide it by 12, because that's a monthly rate. All right, so I've color coordinated it here like so, so you guys don't miss out the link. What we would get is, let's see, 6%, or in other words, 0.06 divided by 12. That would actually get us 0.005. In other words, that is 0.5%. So 0.5% in other words. Now that we've figured out our adjusted interest rate at the monthly compounding period, what we then do is we can write a recurrence relation. So the recurrence relation, remember, is finding out the value period by period. Here we're talking about months, so month by month. All right, pretty tedious stuff. So write down a recurrence relation that can be used to describe the value. Okay, so we're going to use the pronumeral V of his investment at the end of each month. So what we have here is we have Vn plus 1, because that's saying the next month's value or the next period's value is going to be the previous year's value, okay, times 1.005, because whenever we deal with compounding interest, we always got to tack a 1 in front of our adjusted interest rate. the 1 takes into account the previous month's value, basically. All right, without that 1, we just figure out the interest value. With the 1, okay, we can figure out what the total bank value is. All right, so remember, without the 1, you just find the interest. With the 1, you figure out the bank's value and not just interest. Okay, so that's where that 1 comes from. Don't forget it. It's pretty critical. Okay, it's a common error. What is the rule? So whenever we see the rule, okay, we have to think VN. So the value of this investment in any year equals, well, it equals our initial value. So our V0, our initial value, times, okay, times our interest adjusted rate of 1.005. Okay, I'm going to get questions with that, so let's tidy this up first. 1.005. We shut the brackets and we put an N up here. So if it was talking about the value after 7 years, okay, well, what we have to do is we have to make sure we're dealing with the right months. All right. So just to clarify, let's take a look at part D. Using the rule to find the value of the investment after 7 years to the nearest cent. So after 7 years, nearest cent. And we have to find the value. Okay, so notice how it's not interest, it's the final value. What we do here is we take the rule from above. So the value after 7 years, well, because it's compounded monthly, we have to figure out how many months 7 years has. All right, so 7 times 12 will tell us how many months we're dealing with. We're actually dealing with 84 months. Okay, so this N value is always going to be in the context of what it's compounded by monthly. Please, please, please highlight that. Make sure you understand that. Okay, so 7 years. Okay, there's 84 months in 7 years. I'll just highlight this. All right, hopefully everyone's watching the video and not just looking at the notes. But I know people are probably going to shortcut and just going to make sure everyone's, I guess, covered on all bases if they're not going to watch a video. So our V0 value, well, our V0 value was, well, what did we start with? Let's scroll up, 35,000. So Alan inherits 35,000. We plug that in with the V0 value. We multiply this by 1.005 and we power it to 84 because there's 84 months in 7 years. Okay. So, actually, I might just write a side note here. So, actually, no, screw it. Once we've got that, we can basically calculate this with our calculator to figure out the value. So in dollars to the nearest cents, 35,000 times 1.005 to the power of 84. We get a value of $53,212.90. Okay, so Alan's bank balance after 7 years or 84 months is $53,212.90. Right, let's move on and take a look at the financial solver. Hopefully you figured out, or I'll tell you now, compounding interest is the opposite of reducing balance depreciation. So depreciation goes backwards, interest goes upwards. The financial solver technicalities you can find on page 2 of the notes, which is what we're looking at right now. And we're really just going to skip past this and take a look at an example because there's really no point looking at a blank solver. I mean, unless if you want to check out what the acronyms mean or the abbreviations, have a read there. So here we've got an example. Let's use light blue. Karina invested 36,000, okay, in a term deposit, earning 8.1%. This is being compounded yearly. All right, so let's highlight all the important information so far. Give your answers to the nearest cent, which is 2 decimal places. Part A, what is the value of her investment at the end of 5 years? Now, you can do this with the by hand version that we did in the first example, or you could use a financial solver. There's no right or wrong. Eventually, we're going to have to use a solver. So I think it's a good idea to do both just for this exercise, and then pick and choose which one you prefer for compound interest later. All right, but we do need to familiarize ourselves with the financial solver. Here, what we have to figure out is, well, the question asks us for 5 years at the end of 5 years. So end of 5 years means 5 full years. If it was the value at the start of year 5, it would be only 4 years. Okay, so end is actually a really important word. Here let's color coordinate what we did. So end of 5 years is the n equals 5. The interest percentage of 8.1%, well, that's the part in green. Okay, the PV, or the present value, the reason why it's negative is because, think of it this way, right? If you were to deposit earnings and you gave it to the bank, well, technically you've given the bank money, all right? So the bank owes you money, right? So basically think of the bank as not you, and you've lent them $36,000. All right. I don't know if that's making much sense, but if it was depreciation, okay, then you would have present value as a positive. If you were to store money, it's always going to be negative. So whether it's savings, whether it's an investment, investments and savings are always going to be negative. Okay. Our payment is 0. Future value is what we're trying to figure out. PY, CY. Remember, PY and CY, okay, is the number of payments per year. CY is the number of times in a year the interest is compounded. We have here yearly. Okay, so that's why the CY here is yearly and the PY here is yearly. Okay, the payment and other stuff, that'll come later. But for now, that's all you have to fill in with these current details. Remember, use a highlighter or different color pens. That usually helps. And what we do is we enter the data into the financial solver like so. We press a tab button to move down each row, and hopefully you get to the future value and you press enter. So we're trying to figure out the future value here. All right, so our answer is this row right there. I'm hoping that makes sense. So future value, I'm running out of colors. Let's see what other colors we got. What's the color that stands out? Let's go with red. Okay, so red, future value. Okay, that's what we're figuring out. All right, let's scroll back up. So this is what we're figuring out. What we're figuring out. And so you got to go all the way down to that row. In the financial solver and press enter. Okay, so let's just draw these arrows to link these two things up. And hopefully that makes sense. If it doesn't, please comment down below or shoot me an email. I'm sure if you shoot me an email, there's other people with the same sort of questions. So try and ask it on the Google Classroom. Right, let's take a look at the next example. So here we're taking a look at another investment of $12,000. Let's just see what color coding I used last time. Cyan. So let's use cyan again. Investment of $12,000. Okay. But the question structure is a bit different. It's saying how long will it take for an investment of $12,000 to grow to $24,000? So previously we were trying to figure out the end value. Now it tells us the end value. The end value now is 24,000. So color coding is consistent. Invested at 8% per annum. What color did I use for that? Green and yellow. So, and the annual interest rate is 8%. And this one here is compounded monthly and not yearly. So notice the subtle changes. They make a huge difference in the final value. All right, and we're going to take a look at that hopefully when we get to home loans. So we don't know how many years it's going to take. So the part in purple that we had, we don't know anything about this. This is what we're trying to figure out. All right, so this one here is what we're figuring out. What we're figuring out. We know the interest is 8%. We know our investment started at $12,000. We don't really have any payments to make. And we know we want to see the value, I guess, or sorry, the duration it takes for it to turn into 24,000. Okay, because it's compounded monthly. Okay, and the PY and CY we would enter 12. And so we would go to the top row where N is after filling all these values out, and we would press enter to get our total value answer, which in this case is 104.3 months. So 105 months basically. All right, so what we were figuring out is this row right there. So hopefully that's making sense. It's just a game of highlighting and knowing which part goes where in the financial solver. Again, if it's not too clear, just try and link up this section with this section. I don't know how else to explain it. So here we've got our little blurb. Okay, our answer of 104.3 months. If you're wondering how many years that is, well, that's about 8 years and 9 months. All right, so I'm hoping that's sort of making sense. Let's take a look at another CAS example. Whenever we have compound interest, the graph's going to look a little bit different. So Emily has $6,000 to invest. Forgotten the color scheme again. Investment, cyan. All right, so let's highlight 6,000 with cyan again. All right, so now that we've highlighted it, she is comparing two different accounts. One is simple interest at 6.5%. All right, we're not going to, whoops. Doubt. What's just happened there? Redo. Whew. Yeah, little minor technical difficulty. All right, so we've got a simple interest. We're not gonna highlight any of that because simple interest, every year's interest is going to be the same at 6.5% per annum. Here we've got our compound interest rate of 6%, and it's being compounded monthly. So those are our crucial details. Sorry, not monthly, annually or yearly. Those are our crucial details. It tells us to create a graph that shows the value of each investment over a 10-year period on the same set of axes. What you would do is, for account 1, you would do what we did on Friday's lesson in 6.4, right? And yeah, you'll figure out that Emily would generate $390 per year. All right, for account 2, you can use the financial solver, or you could make a spreadsheet of sorts. It's up to you. Whichever method you choose to do is fine. All right, and eventually you'll get yourself an answer. So, what was the duration? It doesn't really tell us the duration, so I guess that's a rule that we have to settle with. All right. So, step 2, fill out a spreadsheet, and what you would do is you would put the rule here for simple interest. Okay, so let's pick some new colors. Let's go with a blue. All right, so this rule here for simple interest. It's kind of scratched out our coloring, hasn't it? All right, so count 1, screw it. That's our rule. All right, and then what color should we use for compound? Let's go with this color. All right, account 2, we've got our any rule of this. Okay, remember the 6%. Damn it. The 6% is that part. Annually is going to relate to the N. And so from here, what we are doing is we're plugging in the rules into a spreadsheet. All right, so the simple interest, they've named it SI, and they've put the rule in the, wow, you really can't see that. In that column. So let's use arrows instead. Yeah, let's use an arrow. All right. Ooh. So there's that rule that we had up in blue. Fill it out, press enter. Don't forget an end column, just so we can see what it is after 10 years or so, or 20 years. Press OK. And then in the second column, we would fill, or third column, sorry, we would fill out our compound formula and plug that right into the third column's row, second row, sorry. And so what you have is you've generated a spreadsheet of all the ELE's value, I guess, over the next 10, 20 years, whatever it might be. And if you put this into a data and stats page, you can click and change the variables to see what the graphs end up being. So the N is obviously going to be down the bottom. All right. And so what you get is you choose N to be in the bottom variable and you choose SI to find the simple interest. And what you can do is if you press menu 2.8, you can plot over it and add CI, which is compound interest. And you can see the compound interest is actually in a bit of a curve. And the reason why banks use compound interest is you generate more money off home loans. Okay, so whilst you generate more money on savings, banks also know that if someone were to borrow money, okay, they would earn way more money with compound interest than simple interest. That's why no one ever uses simple interest, because you lose out on so much money. Especially, see, this is only 10 years. If this went for 30, 40 years, like a home loan, the difference is, 3-4 times, which is massive. Absolutely massive. The next part here is effective interest rates. The interest rates are not always equal. So the per annum rate can change depending on how frequently it's compounded. So the nominal interest rate is the per annum. The effective interest rate is adjusted for the compounding. What does that mean? I think people freak out when they see all this sort of stuff. So what we're going to do is we're going to just do the example, and I'm going to do it with my method. If you want to use the book's method, that's fine. But I think this is the simplest way to go about it. So let's begin. Liana is looking to invest her money. She has done some research and found the best offers from 3 banks. Bank 1 is offering her 8.5%, but daily. Okay. Bank 2 is offering 8.6%, but monthly. Bank 3 is offering 8.7%, but 6 monthly or biannually. Okay, so those are our differences. These are our interest rates. And so what we have to do is we have to figure out which one's the best value for money. In our case here, if we're investing, we have to find the highest interest rate after we adjust it. So which bank should Liana choose if she wants to earn the most interest? So here we want to find the highest effective interest rate. Okay, if it was borrowing, it'll be the lowest. Here's Bank 1. Bank 1. So, just having a think. Yeah, this will be the best way. So the first, well, my preferred way is, I'm just going to show you this way because I think it's the easiest. You would convert the per annum rate into the compounded rate. So if it was compounded daily, our interest rate of 8.5%. So step 1, 0.0845. Again, that's 8.5% as a decimal. If you're not sure how to get that by now, just divide it by 100. All right, hopefully you're familiar with interest rates and how to turn them into a decimal. But what we do is we would divide by the compounded period. So here we've got daily. So we think how many days in a year? We would go, well, there's 365, and this will give us our daily interest rate. So this is step 1. All right, so let's just fence this off. Let's figure out what this is. 0.0845 divided by 365 equals 0.0000232. So this is that would be 1%, 0.1%, 0.02%, so 0.0232% on a daily. What that means is we take this value and we chuck a 1 in front of it. And we would say, well, so here's step 1. What we do is, well, we would power it by the daily, well, the amount of days in a year. So here's step 2. And so this would get us, what would this get us? 1.000232 to the power of 365. This would get us 1.08836. Okay, so that's step 1 done, that's step 2 done. And so step 3, we would take just the back end of this section and we would interpret that. So let's highlight this in green. We would ignore the 1 at the front because that's got nothing to do with the percentage. That's just the part that's including the principal. But anyway, we just look at the part that's beyond the decimal and we say, well, this is actually equivalent to, if you're able to figure this out in your head, 0.08836, that's 8.836%. If you're not sure, just times this green part by 100. Okay, so if you times that green part by 100, 0.8836, you'll get 8.836%. Okay, so this is step 3. So our, sorry, what did I do? Our effective interest rate here for Bank 1 is 8.836%. That's the real rate. If we looked at what they were saying, it's 8.45% per annum, right? But really, you're actually earning a bit more than that because it's being compounded daily. Let me know if you have any questions. Let's take a look at the next one. So the next one is 8.6% being compounded monthly. So Bank 2. Bank 2. I've forgotten what it was. 8.6 monthly. Right. So we would convert 8.6% into a decimal, which is 0.086. If you're not familiar by now, I don't know what you've been listening to, but divide the percentage by 100, you get the decimal. And because it's compounded monthly, so see how it's monthly here, we would divide this by, well, there's 12 months, so we divide it by 12. Let's see what we get. So this is our per month interest rate. So we would get an answer of 0.007167. For these answers, it's important that you write out all the decimals, or as many as you can, just so for accuracy purposes. So that's step 1. we figured out what our monthly interest rate is. Our monthly interest rate is 0.7, so 0.7167%. What we do here is step 2, we tack on a 1. We write what we did before, and we power this. What just happened? We power this to whatever it's being compounded by. Wow. Okay. Right, it's been fixed. So remember how it was compounded monthly? So we have to figure out what it is by powering it to 12. So we go 1.007167 to the power of 12. This will get us an answer of 1.08948. And so that's step 2 done. So this here is step 2. We check out just the points or the numbers after the decimal point. And so this is actually 8.948%. So if you enter the part in green, so if you go 0.08948 in your calculator and times that by 100, you will get 8.948%. And that's step 3. So times that green bit by 100. So which one's got the upper edge so far, bank 1 or bank 2? Bank 1 had 8.836. Bank 2 had 8.948. So right now, bank 2 is the better choice so far. And so finally, we've got one last bank to check through to find the effective interest rate, and that's bank 3. Let's go back and check out what bank 3's percentage was. So the per annum interest rate is 8.3%, and it is compounded 6 monthly. Crap, what was it? 8.7. So we convert 8.7 to a decimal by dividing it by 100. And we would divide this by 2 because it's compounded 6 monthly. Please don't write 6. 6 monthly means biannual. So after every 6 months, the bank will compound. So it's going to do it twice per year, basically. And so what this gets us is 0.087 divided by 2. 0.0435. Okay, so that's step 1. Step 2, what we do is we take this part, our answer in step 1, we put a 1 in front and we power it by the compounding period, which is twice or 2 times a year. And we put this into our calculator. To the power of 2, what we get is 1.08948 8, 8, 8, 9. Okay, and so our final step, we just take the part that I'm highlighting in green, the part that's after the decimal, and we convert that back into a percentage. So here we're looking at 8.889%. If you're not sure, once again, you would times this by 100. Just the green bit. Cut out the 1. And so, which one's the highest or the best option? Let's find out. Once I write down step 3. Let's find out. Bank 1 is 8.836. Bank 2 is 8.948. So bank 2 is higher. And bank 2 is higher than bank 3 as well. So bank 2's of, so let's fence all of this off. So therefore, bank 2's, bank 2 has a higher, English ain't great at the moment. Come on, technology. So bank 2 has the highest effective interest rate. What was the interest rate? 8.948 at 8.948% per annum. Has the highest effective interest rate at 8.948 per annum, meaning if Liana goes with bank 2, she's going to get the most out of her investment. All right, this is really important later on for home loans because what it's compounded by is actually going to change the outcome of how much you pay. So when you're talking about home loans, people are like, oh, what's the difference of something really, really small like 0.05%? Well, that could be $25,000, $50,000 over a 40-year period. Okay, so it is a lot of money. And even though Liana's not investing a whole lot of money, well, we actually don't know how much she's investing. The difference between 8.836, 8.948, and 8.889, from bank 2 to bank 1, could be $10,000 after 20 years. Right? So percentage rates matter, and that's why when the RBA sends out these tiny, tiny cuts, like 0.25% interest rate cuts, you might think that's not a lot, but it really is, especially if you have a multi-million-dollar business that's, upward $500,000 or $500 million, after potentially 20, 25 years. Okay. So let me know how that goes. This is exercise 6.5, and remember to post any comments or questions you have down below.